Welcome dear students, we are discussing the flexible energy storage devices in which we are discussing the various methods for the preparation of flexible energy storage devices. So, in this series we are discussing the various methods. So, now we are discussing the laser scribed carbon based electrode preparation. So, by using the laser we can prepare the electrode on the surface using the various electrodes. So, various materials we can use, and then what is the process behind that? First, the substrate preparation can be done. So, first is the substrate preparation where the polyimide PI film act as the flexible base. So, on that base a layer of graphite or a precursor material is applied to the surface. So, this fabrication step first contain the fabrication of the substrate. So, a layer of the graphite, that is often a precursor of the graphite oxide or the simply a PI film itself. What is PI? Which is the polyimide. So, is placed on the support or on the base. Now, second step is the laser scribing, means LIG process. This laser beam scans the surface in a specific pattern, and we are preparing the electrode. So, this intense heat, that is from the laser, converts the polyimide into the porous laser, that is the induced graphene. So, what we are seeing here, there is a laser scribed, that is LIG, where we are having a laser beam that scans the surface of the specific pattern, and that intense heat through the laser that converts the polyimide into the porous laser induced graphene. So, the second and the third stage is in the diagram we have seeing that is the scribing and interdigitated comb like patterns, and this pattern maximizes the surface area between the two electrodes, two fingers of the comb, and that to the improve the capacitance. You can see here these are the fingers. If you are able to see that here we are fingers on the substrate. So, these fingers having a particular spaces for the electrolyte. So, when you are seeing that in the last, we are having a gel electrolyte that is coating between these electrodes. So, we are having a various another is a gel electrolyte coating. So, finally, a gel electrolyte or a PVA or an ionic liquid gel is dropped casted onto the laser scribed pattern. So, the gel penetrates the porous graphene structure that provides the ion necessary for change storage while keeping the device flexible and the solid state. So, laser scribing, we are having computer control laser selectivity irradiates the surface. So, this process often called the laser induced graphene. So, that is why it is called the LIG. Photothermally converts the polyimide or the graphite layer into the porous highly conductive graphene. So, it simultaneously patterns the material into the interdigitated electrodes. So, electrolyte coating can be done. So, a gel electrolyte is dropped onto the laser pattern area. So, the gel seeps into the porous carbon structure, acting as both the separator and the ion transport medium. So, this method is popular in research because it is a maskless or allows for the rapid prototyping of the thin bendable energy storage devices for wearable electronics. So, the addition of the electrodes with sharp edges made it easier to create a strong electric field at the corners. So, energy storage performance was improved by this stronger electric field, and which promoted the buildup of electrolyte ions close to the carbon electrode. So, you can see on the screen, this is the flexible supercapacitor. So, this supercapacitor we can prepare. This is the fabrication of the flexible supercapacitor through the laser scribing method. So, the interdigited devices architecture can be rapidly built with the reduced graphene oxide nickel layer by permitting reduced graphene oxide to spontaneously deposit on the laser scribed conductive fabric template. So, while the bottom layer of the nickel functioned as a current collector. So, the upper layer of RGO was utilized as a energy storage. So, in this manner we can have the energy storage devices. So, the all solid state planar RGO nickel based symmetric supercapacitor as a fabricated demonstrated enhanced the rate capability, so increased capacitances and a notable decrease in contact resistance. So, it demonstrated an energy density in a range of 2.25 to 3 at a power density 0.4 to 3 with a maximum aerial capacitance of 12.5 to 2 at a scan where we are having a maximum aerial capacitance which is 12.5. Now, millifarad centimeter inverse at a scan rate of 5 millivolt per second. So, it can hold on to 94.8% of its initial capacitance after 20,000 cycles. It means such supercapacitors can be added to the different surfaces and having the significantly expanding the potential uses of the supercapacitor in the wearable electronics. So, another interesting approach is that has been defined for the laser use of the laser that has been demonstrated by Loyo that define the supercapacitor designed as a multifunctional integrated patch like wearable electronics. Multifunctional integrated patch like wearable electronics. So, they create a multi-purpose smart bandage that can sense the pressure, humidity and energy. So, by using this we can measure the 3 parameters, we can sense, we can check the humidity, moreover we can use the similar devices as a energy storage devices. So, band aid like a band aid woven fabric was coated with the green sodium, we are having the lignosulfonate. So, that is the slurry type of solution, that is SLS. Then a quick laser scribing procedure can be used to quickly create a laser induced sulfur doped porous graphene electrodes. Laser induced sulfur doped porous graphene, that is LISG electrode. So, you can see on the screen that this is a method where we are having the, that is lignin that dissolving in the solvent. After that, by dropping it by using the dropper method, using dropper on the substrate, then there is a laser writing and washing through which there the pattern can be designed, and that is the underside. So, this is the pattern and you can see this is a development process of the LISG electrode of supercapacitor on the band 8. This is the bandage, and on that we just preparing a supercapacitor, pressure checker and moreover the humidity sensor. So, that similarly a single device can work simultaneously for the 3 parameters. So, after assembling the obtained LISG interdigited electrodes, supercapacitors were able to provide an exceptional aerial capacitance of approximately 68.6 millifarad centimeter inverse. Additionally, another engraved LISG spiral electrode was coated with the graphene oxide to enable a enable a broad range of humidity detector, that is work under the 11 to 97% of RH. You can see here, this is a spiral type of structure, that is the humidity detector that can detect approximately 11 to 97% RH. So, in addition, a capacitive pressure sensor with a wider sensing range, that must be 2.92 Pascal to 300 kPascal. So, that is the outstanding sensitivity that work in the quantum sensor were assembled using a polyvinyl alcohol and glycerol. So, PVA or glycerol, we can use the dielectric layer film and highly conductive carbon nanotubes material embedded in a cotton pad on the back of the band. So, the photograph we have seen that LISG electrode consists of the interdigited and the spiral pattern, and the CNT sponge electrode on the back side of the band-aid. You can see here that we can check the humidity and MSE and energy storage. So, this is the flexible, this is on the band-aid. So, that can be used further. So, fabrication of the smart wearable band-aid using the sustainable material derived from the lignin. So, that process integrates energy storage and multimodal sensing onto a comfortable, flexible substrates. So, we can see here. So, these are the process. First, the material preparation, that is the lignin is extracted that from the tree, that is a biomass, that is like a slurry. So, dissolved and then dropped onto a standard band-aid fabric. After that, laser induced sulfur doped graphene, that is LISG, a laser scribing process, that refers to laser writing type of process, is used to convert the lignin coated fabric onto the high conductive porous graphene electrode. So, after that the CNT integration. So, carbon nanotubes that applied to the underside of the bandage to provide the additional functionality or the structural reinforcement. Another is the cleaning. So, the process includes a washing step to remove the residual precursors or the unreacted lignin. So, now we integrate this component. So, these components are integrated. A final smart band-aid features three main integrated electronic system. First is the micro supercapacitor that uses a LISG interdigital electrodes to store the energy, and that providing power for a sensor. That sensor which we printed on that bandage, energy will be provided by through this micro supercapacitor. So, it boosts an outstanding real aerial capacitance that must be minus 68.6 microfarad centimeter inverse 2. So, pressure sensor, which is a sensing area that can detect the physical touch or the mechanical force applied by the finger that can be measured through the pressure sensor. So, by the finger a pressure is given to the sensor, and that pressure, stress and strain, the mechanical force can be measured through this pressure sensor that is on the flexible substrate. Another is the humidity sensor. So, a spiral pattern, that is LISG electrode used for wide range detection of the environmental or the skin moisture, that is in the range of 11 to 97% RH. It often combines the graphene oxide. So, a single bandage have the three you can say the nano devices like microcapacitor, like the pressure sensor, like the humidity sensor. So, the integrated system represent a transition towards the next generation wearable electronics that are breathable having the low cost and made from renewable aromatic polymers that is extracted through the plant. So, another method is the vacuum filtration. That method is used for the preparation of the flexible energy storage devices that use the mask assisted filtering. In the previous we do not require any mask, but in this method we require the mask assisted filtering, that is a vacuum filtration. So, vacuum filtration is a low cost fabrication technique to preparation of the supercapacitor electrode using the mask assisted filtering processes. So, a solid and a liquid are separated by a vacuum filtration that producing a stacked dense film. So, this technique offers simple operational steps to prepare the uniform films, that is type of the electrodes with the high energy density. So, for instance, lithium. So, instant we are just replacing the toxic elements through various devices. So, similarly here we use a supercapacitor, and we are previously we use the tree extract. Now, we are here using the filtration method so that we can get the uniform film distribution and the preparation of the electrode on the flexible substrate. So, for instance, there is a controlled one pot method that has been defined by the one of the researcher, that is Lee et al. In his research work, that uses the vacuum induced self assembly, that is VISA process to create a nano fibrated film cellulose, that is NFC, that based composite terms, that is NFCG, means we are having the cellulose type of film that is the flexible, that can be moved, that must be prepared from the various composites with the varying graphite carbon nitride contents. So, the process of creating the composite film that involved the vacuum assisted filtration, that is VAF, combined with the hydrogen bonding and the electrostatic interaction between the NFG and GC3 and 4. So, you can see on the screen that this is here we are just add the two material and then we can prepare the film, and you can see the finally the material is used for the deposition. So, the outcomes showed from this method that we are preparing the composite film that was produced and had a superior specific capacitance, and it is possible to achieve the high specific capacitance. That study offers a simple process of creating a freestanding film for the use as a supercapacitor, which has application in the soft wearable electronic. So, fabrication process and so the fabrication process and the application of multifunctional smart wearable band aid designed for the health monitoring. So, the basic purpose of wearable devices is just for the detection or for the medical purposes as well as flexible electronics in which we use these wearable bands. So, that is designed for the health monitoring. So, the system uses the natural polymer that found in the wood that is used to create the flexible electronics that can sense pressure, humidity, and that can store the energy, and that will not harm the skin or the human being if it is just in contact with the human skin. So, there is a various fabrication method where we are having a sustainable green chemistry approaches. So, here we are having the first step where we just use the material sourcing. So, lignin is extracted from the trees and dissolved to create a precursor solution. After that coating, so lignin solution is dropped or the coated onto the surface of the fabric. So, again laser writing has been done. So, there is a layer integration. So, upside the various methods we can just using this method also we can prepare the various nano devices. Now, in the next fabrication method, just we will discuss the fabrication of MGC electron in supercapacitors. How the another study that has been done by Liu et al. That employed the vacuum assisted filtration to fabricate a film that comprises of the blend of magazines, RGO, CNT, that designated as MGC, because we are using the magazine, graphene and CNT means carbon nanotubes. That is why its name is MGC. So, as essential intercalation materials, CNT and RGO help magazine nanosheets established a stable interlayer structure. So, multidirectional stable ion transport routes are established as a result of this mechanism, means which we are using the layer by layer deposition. So, we are using the magazine, we are using the graphene, we are using the carbon nanotube. So, we can say it is a layer by layer deposition. So, this expansion exposes a greater number of the active site accessible to the ion. So, MGC film prepared under a current density and exhibit a outstanding specific capacitance, having a broad voltage window and having a high energy density and the power density, and that is assembled symmetric supercapacitor. So, we can see it is a asymmetric supercapacitor. So, which has the MnO2 as a positive electrode and MGC film as a negative electrode, that exhibit an impressive capacitance retention rate of 92.9% after 800 cycles. So, this is the one of the method. So, we can have this layer by layer deposition. So, the diagram that illustrates the hierarchical assembly process of the magazine based composite films using the different carbon nanomaterial. So, what are the key components of this process? First, the starting material which we use. So, the process begins with the magazine flakes, that must be of the two dimensional or the two layers. So, which are mixed with either the carbon nanotubes that or the reduced graphene oxide. And then intermediate mixture, these components are combined in solution to create a three distinct hybrid mixture like magazine CNT, magazine RGO, magazine RGO and CNT. First is the magazine and CNT, that is a binary mixture for the MC film. Again, the next is the a binary film focusing on the two dimensional layering, and third is the binary mixture of the MGC film. So, film structure, MC film composed of the alternating layer of the magazine and CNT, where the nanotubes act as a spacer to prevent the magazine restacking. Similarly, MGC film, which is a sandwich architecture incorporating the magazine, RGO and CNT to optimize the conductivity and the mechanical flexibility. So, in this type of film we can prepare. So, these structures are typically designed for high performances applications like electromagnetic interference, that is EMI shielding. So, flexible supercapacitors or the high sensitive sensors can be prepared by using these methods. So, another method is a layer by layer deposition, where the layer by layer deposition is a cost effective technique that offers a simple process to develop the thin film electrode of the supercapacitor. By using these techniques, we can easily tune the thickness and control the mass of the active material. So, that has been defined by the Say et al. That presented a scalable spray coating method for creating the customized paper electrodes for all printed supercapacitors made of polyethylene dioxide, the theophylline. So, styrene we can use for the polymer films, and moreover we can use the cellulose nanofibril, that is optimized electrode thickness and high quality electrodes that were achieved through the layer by layer spray deposition, means we are using the spray coating here. So, the fabrication of spray coated paper electrode for the printed electrolyte, that how we will prepare that? This can be prepared by the spraying the material on the paper. So, these morphologies showed that the spray coated electrodes had fewer agglomerations, producing a homogeneous film. So, this suggests that the spray coating is a superior electrode manufacturing techniques to drop casting. With a aerial capacitance of 9.1, the printed paper based supercapacitor demonstrated sufficient energy to run electrochromic indicators because of the homogeneous and improved contact electrode. And you can see on the screen, this is the spray coating. Here is a nozzle and this is a spray device, and there is a nozzle. That nozzle will spray the material on the aluminum foil, that may be carbon and that may be the paper. So, on the paper we can coat the various material. You can see here there is a current collector on the base, and there is a sprayed electrode, then there is a gel electrolyte. So, this is the method, and we can have the same image or another. So, formation of the supercapacitor based on the three-dimensional structure electrode, that is the VACNTs on MO nickel bilayer with supercapacitor performance, and that is the reproduced with the permission. So, there is a various method for the preparation or the formation of supercapacitor by using the 3D structure electrode, that is VACNTs. So, manufacturing process of the flexible paper based supercapacitor using a spray coating technique. So, key specification and the components of the energy storage devices. First, the material. So, uses the cellulose nanofibrils, that CNF, and the conductive polymers, that is PE dot and PSS for the electrode ink. Then is the structure, that is composed of sprayed electrodes on the power paper, aluminum foil or the current collectors, that is a gel electrolyte we will use. Performance, that displays the low series resistance and the high power density. Manufacturing, it involves the spray coating to form the thin electroactive film followed by the lamination. So, that has been defined by the Dong in his paper. Just he used the layered Pani CNT composite network inside the air laid paper to create the extremely flexible paper electrodes with a high aerial capacitance. So, this method was simple and efficient, and in particular an air laid paper that was used to create a single layer of a Pani CNT composite network using a technique that maximized the Pani loading and deposited Pani particles on the CNT in the precise order. So, because of remarkable rate capabilities and the capacitance of the resulting Pani CNT network, which reaches a higher value, that is approximately 323, and the more layers of the Pani and CNT network were stacked within the paper through the sequential deposition of CNT and Pani. So, these are the various methods. The further we will discuss the another methods for the preparation of the flexible devices and what are its application. Thank you very much.